Sir Arthur Stanley Eddington once said the universe is not only stranger than we can imagine, it is stranger than we can imagine. And indeed, the British astrophysicist was right in his words. After all, we find ourselves in the midst of a world that hopelessly transcends our minds with its size, complexity, and temporal dimension. Peppered with billions of galaxies, stars, and planets, the cosmos is ruled by fundamental laws that show that there are mechanisms and phenomena that go beyond the limits of our everyday experiences and our imagination. But what surreal things are really hidden in the endless expanse of space? And above all, will we ever be able to understand the universe in its entirety? There is no question that the universe, with its thousands and thousands of structures and unfathomable depths, can seem not only overwhelming but also somewhat intimidating. But did you know that fear of the universe even has an official name? Accordingly, the fear of the cosmos and its heavenly bodies is known as astrophobia, cosmophobia, or even spacephobia. And in addition to the frightening emptiness, it often also refers to the hidden secrets of the unknown. After all, we should not forget that from our earthly point of view, we are only able to see a tiny fraction of the big picture, and that we have only just begun to decipher the secrets of the observable universe. No expert knows what wondrous things lurk beyond our cosmic line of sight. But what we do know is that even the formations right on our earthly doorstep could hardly be more alien. Just take a look at the planetary king of the solar system. Not only is Jupiter 11 times larger than Earth, with a diameter of almost 143,000 kilometers, no, in the same breath, our earthly home would also fit 1,300 times into the colossal gas giant. Furthermore, the Great Red Spot, a gigantic hurricane, hunts across Jupiter, which even on its own easily dwarfs our blue home planet. If the Earth were somehow to collide with Jupiter, it would be absorbed into its atmosphere, incinerated, and fused with its gas clouds and liquid metal, just like a drop of water falling into the ocean and thus into its own destruction. And if the drop of Earth were to notice anything of its journey in the process, it would be confronted with whipping wind speeds of hundreds of kilometers per hour before it finally hits the outer mantle of the planet, coming into close contact with a planet-spanning sea of glowing liquid metallic hydrogen. Fortunately, we are spared this unpleasant scenario in reality. So at this point, we still have time and opportunity to remember another remarkable fact. Until the early 1990s, astronomers didn't even know whether other planets existed outside our solar system. But today, we know better. Researchers have already detected over 6,900 exoplanets in more than 4,900 different systems. And yet, this is only the tiniest tip of the planetary iceberg. After all, current estimates suggest that another 100 to 200 billion planetary worlds are still hidden out there, and that's just in our Milky Way. But that's not all. Although official proof of extraterrestrial life is still awaited, a recent study by the University of Nottingham concludes that as many as 36 intelligent civilizations could already be flourishing in our home galaxy. And with the knowledge in the back of our minds that the visible universe is estimated to contain 200 billion galaxies, everyone can calculate for themselves the gigantic numbers of highly developed alien peoples growing on paper. Of infernal planets and stellar giants, however, a glance at the grotesque worlds that have already been uncovered in the depths of space shows that not every exoplanet can be considered a potential alien home. Take, for example, HD 189733b, which, with temperatures of up to 3,000 degrees Celsius and wind speeds of 30,000 kilometers per hour, can easily be described as a cosmic furnace. The fact that the celestial body, which is about 64 light-years away, appears deep blue despite all this is not due to an enormous supply of water but to the razor-sharp tiny glass particles that race through the atmosphere at high speed. It is therefore not really surprising that NASA officially referred to this extreme rain of glass splinters as rains of terror. And yet, these are only planets. But if we let our gaze wander to the stars, the shining points in the firmament sung about in so many children's songs also transform into fearsome giants. In our solar system, the Sun is considered the measure of all cosmic things. No wonder, since our source of warmth and life, with a diameter of almost 1.4 million kilometers, is also significantly more imposing than any other celestial body in our vicinity. It alone contains, believe it or not, 99.86% of the total mass of our solar system. In a superordinate stellar context, however, and this is the astonishing thing, the Sun is only average, and it begins to shrink more and more when we compare it to the other stellar outgrowths of the cosmos. After all, what are 1.4 million kilometers compared to 3 billion kilometers? Located around 20,000 light-years away from us in the star cluster Stephenson 2, the red supergiant Stephenson 2-18 is considered one of the largest known stars in the entire universe. And while its radius is estimated to be 2,158 times that of the Sun, it also has a volume 10 billion times larger than that of our Sun. However, it gets even more surprising when we take a closer look at the almost ridiculously large structure in the constellation Canis Venatici. In fact, we are looking at a luminous quasar here, an active galactic nucleus called TON 618, which is thought to be an accretion disk of hot gases around a supermassive black hole. Well, the term supermassive is actually an understatement. In fact, TON 618 ranks first in the newly proclaimed group of ultramassive black holes by NASA, a rank it has truly earned with its own mass of 66 billion solar masses. However, it should be noted at this point that other studies arrive at a slightly lower mass of only 47 billion solar masses. But what is undisputed, however, is the fact that the hyper-bright quasar outshines its home galaxy to such an extreme degree that it can't even be observed from Earth. Expressed in figures, this means nothing other than that the brightness of TON 618 is -30.7 mag, or, in other words, that it shines 140 trillion times brighter than the Sun. If we now also consider that the Schwarzschild radius of TON 618 is estimated to be 300 astronomical units, which is 40 times the orbit of Neptune, the question quickly arises as to what cosmic structure could possibly be larger. The answer? Nothing seems obvious here, and if you like, it's even correct. After all, Boötes void is sometimes referred to as the Great Nothing. In detail, we are dealing here with one of the largest known voids, or, in other words, low matter cavities, in the universe, which has a phenomenal diameter of 300 million light-years. By comparison, the diameter of TON 618 is just 1/25 of a light-year. And while the vast structures of the universe are undoubtedly awe-inspiring, the processes that take place on a relatively small scale are no less astounding. First of all, there is the material difference of the cosmos. While matter on Earth usually has a solid, liquid, or gaseous state, 99.9% of the normal matter in space is present in a completely different form as plasma. Our Sun also presents itself as an oversized ball of plasma and, in addition, as a stellar alchemist. Because every second, our mother star fuses about 600 million tons of hydrogen into helium. While the solar fusion engine is running relentlessly, it produces not only new elements but also enormous amounts of energy and light particles. So, the bottom line is that the Sun not only turns on natural light, it also ensures that there is a huge bang in space around the Earth. This explosive display is called magnetic reconnection. And while we can't see it with our naked eyes, its effects are sometimes visible. This is the case when some of the solar wind particles collide with oxygen atoms in the upper atmosphere, magically creating swirling auroras.